for a user. And I'd like to start at this end over here and give you a quick idea of what carbon fiber is, for those that don't know what carbon fiber is. Carbon fiber, it's a man-made product. It's the strongest product made to man. Uh, it's a fiber. It's like yarn. All right. If you were to take a piece of yarn and stretch it and wrap it around your hands, the tighter you pull, the stronger it gets. Okay. But you can cut it so it's got little shear value. But as far as tensile strength, it's 5 times stronger than the tensile strength of steel. All right. Carbon fiber is rated in 3 different strengths. You have medium, you have a low grade, a medium grade, and an aero grade. And how do they do that with carbon fiber? It's just like if you were to take a piece of timber and it's got a certain amount of strength to it, that piece of timber. If it's got bark on it and you refine it and you keep stripping the timber, the bark off of it, that piece gets smaller and smaller, but it doesn't diminish the strength. So here's how they rate their carbon fiber. If you had carbon fiber strands that haven't been refined to make it thinner, you can only get so many in a square inch area. If it's refined and it comes down to 100 times smaller than a human hair, you can get millions in the same area. That's how they make that product stronger. All right? In a compression beam, let's say this is a beam like this beam that we have over here, or that wood beam, if you push down on this, that fibers that are in the bottom piece of this, they can't stretch. And the more fibers you put in there, the stronger that becomes. Okay, so that's what happened. Let's get back over to carbon fiber. Now the industry knows that carbon fiber, being strands, is wrapped in plastic. Let's call it plastic. It's a resin, and they make different resins with different strengths to do different things. So if you encapsulate all of these millions of fibers in a resin that captures the fiber, and you can make a shape, turn it into a shape. And the industry knows that. Unfortunately, there's 2 things that you can't do with a carbon fiber beam like this. You can't drill a hole in it, and you can't rub on it. Those are the 2 things that the industry knows, beyond a shadow of a doubt, that's the downfalls on a piece of carbon fiber. And here we have Boeing. Boeing just flew 100-something planes in from Japan, and when they landed on the ground, they were very lucky that they all landed. When they inspected the wing spars, because they drilled holes through the carbon fiber that they made the wing spars at, and what that does is, imagine a windshield on your car. You get a rock that hits that windshield and it splinters, and you can watch those cracks grow as a vibration, or so even though they were micro cracks, they still grow, and that's a weak spot. And if you were to take a ceramic cup, a drinking cup, and had fibers in the structure of the drinking cup, in the clay, if you were to take a file and rub on that, eventually you would hit the millions of fibers. And like I said, you can take a fiber and it's got no shear value, you can cut it. So what that rasp does, or whatever's rubbing on it, breaks the fiber. Now you can't pull the fiber, remember that, but you can cut it. Think of a ponytail on a girl's head, right? You pull it and she's gonna follow you, right? But you can cut it, and you can cut that whole piece off. So what we did is, knowing that the industry has a problem, right? We tried to find a way, let me just turn around, and this is one of Boeing's patents, and this kind of gives us validity of what we're doing. Boeing took an I-beam like that, and they milled out the top, and they took a carbon fiber plate that's in here, and they glued it in there, trying to give them more strength on the bottom and their top flanges. but that is only as strong as the glue that they used to put it in there. So that didn't work for them. And we disputed that, and I don't believe they ever got that patent. The second thing the industry is trying to do, and this is all the universities in the world, and this is top industries, is they've come up with an idea to try to glue it. So just like they glued it in here, they're trying to put glue plates. This happens to be another Boeing patent. This is the seats on a plane. Evidently, they have a lot of trouble with the aluminum that they put on the floor. If there's a plane wreck, the aluminum seat bracket just comes loose from the floor. So they're trying to reinforce it with a thin piece of carbon fiber so it doesn't stretch or pull. That didn't work for them either. So knowing that the industry has this major problem, what we did is, under this patent, is we took carbon fiber and we encapsulated it in a steel beam just like this, and this picture over here. What that does is that allows us to protect the carbon fiber. And it gives us a means by which we can attach that to different things now. Take a bridge abutment, right? Now we have steel, just like conventional steel beams that hold bridges up. Wherever the attachment is, they don't want that to move or vibrate, all right? In the old system, and there's a company, I won't mention their name, that is building 36-inch double web beams, and they started this project 10 or 15 years ago, and it was great. That beam, for their strength, is known all over the world. But the problem is, the industry does not want them to use it because there's movement, and they have to drill 100 holes in this beam. And every time you drill a hole in it, you have those micro cracks that in time, that bridge is going to fail. All right, so this is what we did. This is part of the patent. We encapsulated it. This is a picture of the carbon fiber beam that's over there. This is a picture of that steel beam that's on there, on the table. And this is the little piece of carbon fiber that's in it. And what that did to that beam is it made the beam almost 5 or 6 times stronger than the steel itself. And that's what we were trying to do, capture the strength. What that allows us to do now is make a smaller beam, a lower profile beam, and give them the same amount of strength, and at the same time make it applicable where they can weld this to other pieces of steel or bridge abutments or anything else, no holes. So we had all of this tested. We came up with an idea. We had it tested at Washington State University, and then we run an independent test lab at Applied Technical Services, and we got all the data on that. So knowing that the concept worked and the idea worked, we turned around and said, okay, that's a great idea, and a lot of people like it, and we think that, you know, this could work. So what we did is we took it to an IMPEX convention, which happens to be an inventors convention. And lo and behold, we were inundated by architects and engineers that, I mean, their main question was, how fast can we get it? You know, how strong can it be? And there was a million questions. And it was, I mean, we were running at the convention 3 and 4 engineers and architects deep among a lot of other people. We took their awards for engineering, special technology, and construction with this idea. Let me also say that at the convention, all right, let me say one more thing about the carbon fiber. This beam that we have over here is just a 4-inch beam. It's just a test prototype beam. It's got the minimum amount of carbon fiber in it. We just wanted to use that to find out, and the engineers know that the more carbon fiber you put it in, and the key to it is that if this is a 4-inch beam made out of carbon fiber with a certain amount of carbon fiber in it, they can calculate what a beam 4 times that size would be and how much carbon fiber goes in it. And to my surprise, not being an engineer, as I found out that the strength, when it's 4 times higher, like, it goes off the chart. I mean, it quadruples its strength. So if you got 6,000 pounds here, you got 24,000 pounds there. And if you were to do that like they did in here and put it under a 3-point test machine where they put 6,000 pounds on here, that beam is actually, can handle approximately 15 tons or 30,000 pounds. And it even surprised us. So after the IMPEX convention, we found out that there is a need for it. We put some paperwork together. I got in touch with people up there in the tank corps up in Warren, Michigan, and they were interested. And they turned around and said, okay, send us a prototype. So I didn't have the money to build a prototype, and that's what this is all about. At the IMPEX convention, we not only ran into a group of fellows from Canada, Ron Summers, and another group from the UAE that was interested in a trailer that they invested in so we could design the trailer, and that happens to be this trailer. Nobody's ever seen a trailer like this. It splits in two spots, and these boys up there in Saudi Arabia were making 80-foot sticks, two 40-foot sticks, 36 inches in diameter, and sticking 4 inches of concrete on it. And when they put it on a conventional trailer and spread it open and went down the road, the middle piece broke the welds. And these were made for underwater pipes for one of the countries in Saudi Arabia. So what I did is I designed the trailer to where we can buckle it down in the front, in the back, in the middle, and that stabilized the well. And that was their investment. Not only those two that we met at the IMPEX convention, we opened the door to, I was inundated with emails from global emails, right, from 50, 100 different companies, like the third or fourth week after the convention. And these are the ideas that they had. Can you make mining beams stronger? Yes, we can. We know that we can make stronger trailers. I mean, that opens the door to the tank trailers in the military, and there's 5 other designs specifically targeted for the truck trailer market. Any kind of overhead crane or any cranes, all of the structures that are in here, we can make it so much stronger by using this technology, all right? Bridges, railroad ties. The bottom stringer on a truss here, if that's reinforced, that'll make that truss 10 times stronger than what they're making now out of conventional metals. My idea, I flew into a couple of airports and I had to bite my bottom lip because there was snow on the ground and we didn't know if we were going to make some of them. So I made a tunnel with carbon fiber bridge beams on here that could support suppression systems and lights and heat systems, and there'll be no such thing as an airport that a plane couldn't land at. To me, that was a biggie. This beam being a third lighter than steel, or even lighter than that, if they would incorporate it in, let's say, a simple aircraft carrier for the military. And I spoke to a couple of people not on the SecNav level, but that were Navy boys. And if we can make this ship a third lighter, the military is interested in that because they can cut it through the water a whole lot faster. This is pretty self-explanatory. I don't know how many people have had friends and relatives in a car accident, but we put a thin strip in that guardrail, this would never happen. I have friends at the fire department up in New York that were interested in this, and they've kind of sent us a couple of dollars to help promote this. And this is a fire engine truck ladder, right, that they standard makes maybe 150 feet. With that carbon fiber in the superstructure, we can double that. All right, I mean, look at the reach, look at the potential on that. So knowing that we have the strength, we've cured an industrial problem by encapsulating it, all right? I've been in the trucking business, I've been in the construction business, I've got a pretty good fair idea of what could be made better, all right? So this, when we honed in on this steel beam here, oh, by the way, this only weighs about, if this was a steel beam with the strength that it gave that, we're talking about 1/10 of the weight. This thing weighs probably 11 pounds, and this weighs 100 pounds. So we made it a lot lighter. We honed in on 3 products over here. Let's say we took this steel beam, all right, the same identical carbon fiber in here to give this strength that an engineer needs for a bridge beam or one of the rollers on a overhead crane or a lifting beam, a commercial lifting beam, right? The technology is all the same. So the material and the mechanics of it is all the same. So we can make these products. The last board over here deals with. I'm no financial engineer or anything like that, but I do know what it costs to run machinery. We've investigated the cost of protrusion machines and mold injection machines and all the tools that we need. And like I said, being in the trucking industry and being in the excavation business, I learned one thing, okay, is the best way you can set up your shop and your plant to be self-sufficient. You have a lot of machinery running this, right? And you don't want to outsource anything. You don't want to outsource this carbon fiber beam because the industry says, okay, you want that carbon fiber beam? Hope you're willing to pay for it. So we can manufacture it themselves. How do I know that? Because I took this beam, which happens to be stainless steel, for bridge beams. That's a no maintenance type beam. I don't know if you guys can hone in on that. And we called up California and they said, sure, we can build you an autoclave, 12-foot autoclave. It's about $250,000. I says, no problem, I'll get back to you in the morning. We went to Elko, Nevada, and we built the autoclave, right, for less than $5,000 out of 55-gallon drums. An autoclave has pressure, heat, and vacuum. Simple. They said we couldn't do it. We did it. We not only produced carbon fiber, right, we ended up producing a piece that was thicker than anything the industry or university has ever made before. This piece came out to be approximately 2 inches by 3 inches, homogeneously cured. We took it to a couple of carbon fiber people and they want to know how we did that. We took it to the manufacturer that gave us the carbon fiber. They want to know how you did that. I had a lapse. I couldn't remember how we did it, but we did it. So being a chemistry major, I know the chemistry, okay? We can do this ourselves. We don't need, if they're gonna gouge us on the price, we'll do it ourselves. The mechanics, and in this list over here, we turn around and I have a list of an R&D shop, which I had a young man that was the senior analyst for Goodyear Rubber, Dan Rocap, gave me a number on what it would cost. So these numbers over here for $2.8 million is just the machinery that's going to take to set up an R&D lab, a metal fabrication shop, a welding shop, a machine shop, 6 protrusion machines, and 6 mold injection machines, plus overhead cranes and any other tools that we need to run. And I estimated about a 200,000 square foot building, which is enormous. But once you set these 200-foot protrusion machines up, you're going to run out of room. The bottom piece over here, let me get this out of your way, simply says that a protrusion machine can produce carbon fiber at about 3 to 6 inches per minute. So I took the low end and I said 3 inches per minute. If I produce carbon fiber at 3 inches per minute, at 60 minutes in a day, that gives me 4,320 inches per day. If you divide that by a 20-foot beam, which is twice the length of this, that brings it down to 18 beams a day. Don't sound like a lot, okay? But if you got 18 beams running 45 weeks a year, and I figured 45 weeks, if you have breakdowns or, you know, kid catches a cold and you gotta shut it down or revamp or anything. The bottom line is we're producing 4,050 beams per year per one machine. We can sell these beams. A standard 36-inch girder steel beam runs about $200 a linear foot. Our price, we can kick it out the door, wrapped in steel and everything else, for about $821. All right, that gives us a profit of a year per one machine of $3,327, $480 per machine. So if you can do the math, if you have 6 machines running, that's what we're asking for. But most of this was, I'm asking for enough to set up a totally self-sufficient shop, so we don't have to depend on anybody. Because this right here, they're gonna charge us 500 to 600% more than what they're paying for it. And that would take this whole idea and just blow it right out of the water. We couldn't compete with them all. Now, like I said, we went to the INPEX convention and we ran into a gentleman or two up there that started working with us. In fact, the fellow that makes the overhead cranes, Ron Summers, is here, and I'd like to get him up here just to let you know what the industry needs in his field. Mr. Summers?
Do I need that? It's on.
Thank you, AJ. It was a pleasure meeting you, and it was a pleasure dealing with you through all these trials.
And we've had a few.
We've had a few. And as soon as I heard that you were encapsulating carbon fiber into metal, what that could do to our industry in the crane, overhead crane manufacturing, and also monorails, to lighten the structure of a overhead crane system would result in lightening the structure itself of the building. It also would give the end user more headroom. So with that being said, we've had requests for a lifting beam as well. A lifting beam in the aluminum industry was supposed to be 40 feet long and going to lift the capacity of the crane, which was 3 tons. The lifting beam alone weighed 2.5 tons. Our interest in the carbon fiber just escalated a little more, because now, and they are still very, very interested in producing lifting beams. And if you've got 6 machines running to do carbon fiber beams, what would happen if you run them 24 hours a day? Because if you only run one shift, you're not going to keep up with production, with the requirements of the industry. Because overhead cranes is not the only thing. There's monorails, like I mentioned. There's your mining industry, telephone poles, you name it, swing stages, concrete. You have mentioned carbon fiber beams encapsulated with concrete. So what would be your answer on that?
We'd have to take the carbon fiber and coat it to protect it against the chemicals that are in there, but they're doing that now with carbon fiber industry is making rebar now, and they're coating it. They're experimenting with it. The only problem that they're gonna have, as far as I'm concerned, is that our patent for carbon fiber states that any building material that encapsulates that piece of carbon fiber, and they're using the outside industrial element for attachment, right? They're infringing on our patent. Now, I'm open to licensing or anything like that. In fact, I welcome that, all right? Because the more we can get people involved, the faster this whole thing will grow. The key is to keep the cost down and help them in whatever business they're in.
Okay. So in our industry, we would end up doing a lot of testing to satisfy the safety boards and whatnot for overhead lifting, and there have to be a lot of destructive testing done. After that would be a lot of trade shows that you would have to be visiting across the country, not only in the US, but Canada as well. At that point, it would be more advantageous for you to focus on something that could be done immediately.
And I think we've got the answer to that question,
I
right?
think you do.
I think we'll turn the floor over to Nat Crouch.
Thank you.
Thanks.
Thank you, AJ.
Yes, sir.
Thank you, sir.
I'm Nat Crouch, been in industrial sales. I have worked
Okay.
closely with several lumber companies, and there's a big need right now for additional strength in home construction, where you have more open floor plans and larger areas that have to have more strength. We could take this beam, and as is illustrated here, insert it into a laminated beam. That laminated beam would have a lower weight, a higher strength, and it could be assembled and put in place by a couple of guys instead of a lot of lifting machines, lifting apparatus. So what we've got fewer SKUs for a supplier to keep, got a higher weight range, a lower footprint, and an ease of putting the beam in place. This would, the company I'm working with is located in Virginia. That's where we do our qualifying. They have offices in North Carolina, South Carolina, Tennessee, and Virginia. They also have, in my discussions with this, that we think we could place this in other markets that in construction for decking and things of that nature, where you need a high strength post that would be reinforced, which is great. So I asked them what kind, if we could get the product approved and put in place, what kind of quantities they would like. I said, well, we only buy truckloads. So whatever a truckload is, we need to figure out how many we need on that. I will be working now that I have AJ's independent testing lab data. I will be getting together with these folks either in Prince George County or in Greenville, South Carolina, and go through their technical people. And now that we have the independent lab stuff, we can start working through their program. Once this hits, we'll probably have to do a few tests, make sure everything comes up. But I think the sky's the limit on this. I mean, it can go into technical woods where you're actually building beams, very light beams, and just lower the size of the beam, but have more strength. And it just is a natural fit. Once we're successful with that, I have contacts at the biggest laminated beam manufacturer in the country. And once we cut our teeth here, we'll answer all the questions, and we'll take care of this company, and then we'll go see the big boys. And that's where we'll sit down and capture our cash cow. And we'll keep everything running. So AJ can run 3 shifts a day and be called at 4 o'clock in the morning to come out and fix a problem. He loves that. Anyway, so that's what I have. I have other ideas, but first things first.
Thank you, Nat. Appreciate the help. I was just handed this little piece of paper, and it was a biggie that we had worked on as far as protecting our investors. All right? The products that we're into, they all have to be tested. But how do you protect the investor that's gonna put in $10, $20 million, all right? I'm not a genius when it comes to numbers, but I do know how to protect my corporation, all right? And it's been suggested to us, not only for the patents and the amendments and the changes that we make, and anything that we build as far as bridge beams, there's standards on it. There's standards on a bridge beam right now. If you use steel, there's certain standards. Somebody wrote those standards, right? This is a new product. There's nothing out there like it. We will actually have the advantage to write the standards on anything that we create, all right? Making sure that our investors are totally protected. And anything else that we can add to, to that, we'll do. So we're at a point now where we're trying to entice investors to get involved in this new technology, and you can see it's endless. I had to shut the phone off and the emails because I was just inundated with, can you do this? Can you make that stronger? Where can we do? And it was just like, I didn't have a factory to make the first beam, all right? And that's what we're hoping, that we can entice somebody that believes in us the way we do, okay? And work with us. So I want to thank all my friends and everybody and the people that have taken the time out to come and spend with us to get educated. And I'm sure that at the end of the website, we'll have all the information you need to contact us and get in touch with us. And my email numbers and my personal cell number, and I'll be delighted to talk to anybody that wants to give us the time. So thank you very much. Did I leave anything else out? Has anybody got any questions? No?
I
Good.
have a question, Mr. Cesternino.
Yes, ma'am.
How much of your own personal time and effort and investment have you done to forward this? Sounds like it's a lot.
I've been working on this project, encapsulation, for over 6 years. Me personally, I liquidated my trucking company, the excavation business, and I've got personal money and a couple of donations from Summers boys have worked with us on this, so I guess that's an in-kind value. The UAE boys put in about 30 grand to engineer this trailer, so all total, we're probably looking at about $350,000. So, does that answer your question, ma'am? Anybody else? Good, let's eat.